In this video, I'll be helping you with the ALEKS problem type called special triangles with a hypotenuse of length 1. We're given a couple of 30, 60, 90 degree triangles here, which are special triangles. The other possibility that is a special triangle is a 45, 45, 90. And since the hypotenuse of each of these is exactly 1, we can think back to our unit circle. I'm just going to draw quadrant 1 of our unit circle, where here at 0 degrees, this point has the coordinates 1, 0. At the top here, 90 degrees, this point has the coordinates 0, 1. And then in between, we have 30 degrees, 45 degrees, and 60 degrees. To find these coordinates, we can use the pattern that starting with the x values, over here at 0 degrees we have 1, which is the square root of 4 over 2. Next would be the square root of 3 over 2. Then the square root of 2 over 2. Then the square root of 1 over 2, which is just 1/2. And then the square root of 0 over 2 is 0. To find the y values, I can use the same pattern, but here starting at 0 is the square root of 0 over 2. Next is the square root of 1 over 2, or 1/2, the square root of 2 over 2, the square root of 3 over 2, and then the square root of 4 over 2, which is 1. Now that we have this quadrant 1 with all of the special angles, I can move these special triangles into this and find the missing value. I'll start with the first triangle, and since I have this 60 degrees is here, so that means if I drop down to form a right angle, the radius here of the unit circle is 1, so that's this side. We can see that r would be this value here, the height, which is our y value of square root of 3 over 2. And then for this second triangle, it also has a 60 degree angle. So again, dropping this 60 degree angle to form a right triangle, I can see that P is actually here along the base when I orient this triangle this way. So P is the distance here, which is the x value of this terminal point. So here P will be 1/2.